Welcome to today's lesson. With me here, your teacher, can be honest. This is the class of mathematics, as you can see there on the chalkboard. So this is today's lesson. The diagram shows a right angled triangle ABC. Full stop. BC is produced to D. AC is equals to 13 centimeters, and cos BAC is equals to 12 over 13. Then question says, find the value of tan ACD. Okay, so this is the diagram which they are talking about. Okay, so here we have ABC. Okay, then we are given, they are saying BC, which is this one, BC is produced to D. So BC is produced to D. Okay. Then AC is equals to 13 centimeters. Okay, so we are given 13 centimeters. And cos BAC is equals to 12 over 13. Now, the question says, find the value of tan ACD. That is what we are going to do. Remember, in mathematics, when you are given a question like this one, what is it that you are supposed to do first? You need to identify the question. Otherwise, I should not stop reminding you of this. Why? This is very important. Identify the question. So this question is coming from trigonometry. So having it in your mind that the question is coming from trigonometry, it will be very easy for you to actually work out this particular question. Okay. So how can we find the value of tan ACD? So here, since the triangle that we are given is the right angled triangle, so for us to find this particular value for tan ACD, we need to use the trigonometric ratios, okay? Where we are going to introduce the word called SOHCAHTOA, okay? We are saying SOHCAHTOA. Okay, what does this mean? Sine is equals to opposite over hypotenuse, then cos is equals to adjacent over hypotenuse, then tan is equals to opposite over adjacent. Okay, so you should have that in your mind for you to remember the trigonometric ratios. Now, having introduced this, now we get back to the question. What is it that they are looking for among these three that we have? There we have sine, cos, and tan. So now, according to the question that we have here, they want us to find the value of tan ACD. So we are here. Okay. So the ratios for tan is equals to opposite over what? Adjacent. So now, let's get back to the diagram that we have and see the sides which we are given. So, according to the information there, the statement, we are given this side. Okay? This side which is opposite the right angled triangle. And this side is called the hypotenuse. Okay. So now that you have come up with the trigonometric ratio here now, you have to identify the sides, name them accordingly. Okay. This is very important. So this is hypotenuse. Always remember that the side which is opposite the right angle is called the hypotenuse. This is the one. Okay? So hypotenuse in this case, we are given, which is 13. Now, do we have hypotenuse on the tan? No. So now, let us identify even these other sides. So we come to the other side. Which one is the opposite and the adjacent? So now, looking at the angle, the targeted angle, which they have actually asked is this one. Okay? The exterior angle, which is ACD. It's this one. So our angle in this case, for us to identify the other sides, which is opposite and adjacent, we are going to use this interior angle which is there. So remember, how do we identify opposite and adjacent? So now that you have this angle, it is very easy for you to know which one is which one is opposite and which one is adjacent, because you have this angle. Remember, when identifying the hypotenuse, we use the right angle, but for these other two sides, you have to use the angle which is being targeted. So here we have this one as our angle. So opposite in this case, when we talk of tan, is the side which is opposite to this angle, which is this side. So AB is the opposite in this case. And the side which is next to the angle is the adjacent. So this one is adjacent, okay? And this side is the opposite. So this is how we identify the side, the opposite, and hypotenuse. I'm sure I've made myself clear on that point. So having known this, it is now very easy for us to proceed. Now let us look at what we are given. Are we given opposite on the diagram? No. Adjacent is not there. It's only hypotenuse. So let's get back to the statement that we have. I'm sure we are given these two sides. So we are saying cos BAC, which is cos BAC, okay, which is this one in this case. Remember, I was just explaining on the actual question. Now, let me also explain on the statement which we are given so that we can see the side which we are given. Okay? Already, we know that we are given the hypotenuse, which is 13 centimeters. So, let's come now to this statement and see which one is the adjacent and hypotenuse and also the opposite. So the cos BAC, this is the angle in this case. So which one is our opposite? So first of all, let's come to cos. Cos, we have adjacent over hypotenuse. This is the cos. So among this that we have here, the one which is on top is the adjacent. Then down there is the hypotenuse. Are we together? Then from there, you are going to say, since the one on top is the adjacent, and remember the angle is here, okay? So the opposite is BC. Adjacent is the side next to the angle, which is this one. So this side is what? 12. Okay, because cos is adjacent over hypotenuse. So this side AB is 12 in this case. Okay, so we have and the side which is down there, hypotenuse is 13. This is the one which is even there. They have indicated it for us. Okay, so now that we have come to know that this side and this one is 12, and this is 13, I'm sure it is going to be very easy for us to even find tan ACD. Okay, so now tan ACD. So in this case, this is the angle. Opposite we have. Okay, when we are talking of tan, the opposite is this one. Okay, so opposite we have, it is 12. Then adjacent, do we have adjacent? Because it's opposite of adjacent. Do we have adjacent? No, we don't have. So now that we don't have adjacent, what are we going to do? Okay, here now we are going to use Pythagoras theorem for us to find this side, because this is right angle triangle and we are given two sides. So it's very easy for us to find the missing side by using what? Pythagoras theorem. That is the one we are going to introduce there. So Pythagoras theorem states that this is always, remember, let me first use this the first three letters of alphabetical order, which is A, B, C. So C squared is equals to A squared plus B squared. Okay, so that is the formula for Pythagoras theorem. So now let me talk about these letters. So this C squared representing hypotenuse. Okay, then A is representing adjacent. Then B is representing opposite. Okay, so now in this case, which one is our adjacent? So adjacent we have is 13. Okay, this side. So it's what? 13. In this case, it is AC. So we can say AC. AC squared is equals to, okay, which one is our adjacent? Adjacent we have is this one, BC. Okay, since the angle is here, so BC is our adjacent. So we are going to say BC squared plus opposite BA or AB. AB squared. Okay, so let us substitute accordingly. We are going to start with the hypotenuse. So hypotenuse is 13. So AC we are going to write 13 squared is equals to. Then BC, are we given? No, we don't have BC here. The only thing that we have is AB. So BC, we are going to write it the way it is. Then plus AB is what? 12. That is what we identified. The adjacent here is 12. So we are going to write 12. 12 squared. Okay. So now here we are looking at, we are actually solving for this value. So for BC, we are solving for BC here, okay? So we are going to say, let us swap this. We can actually swap this. Since when we are calculating, remember that is an equation. So we always make sure that the numbers with variables lie to your left hand side. Then this constant number to the right hand side. So let's try to swap. Since this side we have got this one, which is variable. So we are going to say BC squared plus 12 squared is equals to 13 squared. Remember, 13 squared is equals to BC squared plus 12 squared is same as BC squared plus 12 squared is equals to 13 squared. So there's nothing different there. They are just one and the same. Okay, we have just swapped them. Okay, so now from there we can correct the like term. But before correcting the like term, let us actually evaluate. So BC squared plus 12 squared is 144 is equals to 13 squared is 169. So now from there, since we are looking for BC, so we are going to correct the like term. So 169 I mean, this is positive, 144 is positive. So when it crosses an equal sign, it will become what? Negative. So it will be negative 144. So BC squared is equals to, when we subtract there, what are we going to have is 25. So here we are looking for BC, not BC squared. So we are going to introduce the square root both sides. So this square root is the half power. We are going to cancel with the power which is there. So BC is equals to, what is the square root of 25? Is 5. Okay. So our BC in this case, BC is equals to what? 5. Okay. Here we go. So now it's very easy for us now to find tan what? ACD. Tan ACD. Okay. So we have the opposite, we have the adjacent. So it's very easy. So how we are going to say now? Tan ACD is equals to, what is our opposite? In this case, our opposite is what? 12. Okay. What is our opposite? This is the targeted. So our opposite is 12. Our opposite is 12. Opposite. So katoa, that is opposite is where? So katoa, opposite of adjacent. So our opposite is 12 in that case. So 12 over adjacent is what? 5. So our adjacent, according to the tan that we have here, is 5. Okay. So now from there, we are saying we are now going to bring the idea of quadrants. Let us look at the quadrants now. This is obtuse angle. So that means this is found in the second quadrant. So what is tan in the second quadrant? Because what we know is in the first quadrant, we have in the second quadrant, in the first quadrant, all angles are what? Are positive. Second quadrant, sign is positive. Third, so in second quadrant, it's only sign which is positive. So this is tan, so it is going to have a negative. Okay. So this is going to be over 5 negative. Negative 12 over 5. So that is the way to go. Thank you so very much for your attention and your patience.